This is a demonstration of how to use the Proton Nmr Exercises tool. So you'll find it under Proton Nmr Exercises in a table of contents in your course. If you click on this, you'll go down and you can see that there are, if you load more, a total of 75 problems that you can do that will help you to understand how to complete NMR exercises. Up the top you've got some important information. It says rotate methyl groups only. I'll explain what that is in a minute. And over here you've got the answers, and these contain the peak labels as well. And you can use this if you happen to get stuck on any of the problems. I'm going to show you an example of how to use the tool. So this one's compound 34. You can see it looks like any typical NMR spectrum would. You see the peaks, some of them are split into smaller peaks, and you'll see numbers above the peaks as well. First thing we want to do is realize that the molecular formula is presented here, C11H14O2. Our first step is to calculate the number of double bond equivalents that are present. If we do this, we can see that 11 times 2 is 22, plus 2 would be 24, minus 14 would be 10, divided by 2, which is going to be 5. So there's 5 double bond equivalents present. Once you do that, you can see all of these choices come up for the pieces that we see in the spectrum. Over here we have a 5H. This would be an aromatic ring with 5 hydrogens on it. Over here we have a 1H, and since it's a multiple peak, it's going to be a CH. Over here we have a 2H, again a multiple peak, so it's going to be a CH2. This here is a 3H, that's going to be a CH3, and another 3H, that's going to be a CH3 as well. Now what I want you to notice is that as I selected the pieces, the molecular formula went down. I'll remove this last picked piece so you can see this. So currently it's C2H3O2 with 1 double bond equivalent. So I'll just click on CH3 and you can see it took 1 C and 3 H's away. At this point I've selected all the pieces that I can see in the spectrum, but there are clearly atoms left over. The reason these atoms are left over is because they don't have hydrogens on them and they're therefore not shown in the Proton NMR spectrum. What we have left is a C, 2 O's and a double bond. This suggests that we have a C double bond O. This will take 1 C, 1 O and a double bond. You'll see that as the molecular formula goes down. Now all we've got left is 1 oxygen, which would be this one here. Now that we've selected all of the pieces and everything has reached 0 here, the continue activity button has become available to us. I'm going to click on continue activity and see what happens when we go to the next screen. So now you are presented with a field onto which you can put the pieces and connect them together to form the compound. So I'm going to pull these over into the field and we're going to see how we can put these together in a way that makes sense and matches the spectrum that we're given. Now what I'm seeing here is a CH or a 1H at 4 ppm. This indicates that the CH is likely connected to a single bonded oxygen atom. So I'm going to go ahead and do that and connect the CH to the O atom. This CH here has 1, 2, 3, 4, 5, 6 peaks, which would indicate that it is next to 5 hydrogens. The way to do that would be to put it next to a CH2 and a CH3. Following the directions that I showed you earlier, we are allowed to rotate only CH3 groups or methyl groups within the field of the structure. We can rotate the methyl group by right-clicking on it and rotating it either clockwise or counterclockwise so the bonds line up. We're going to rotate this one clockwise and now the bond will line up. You can see that we have 2 CH3s here. One CH3 has 2 peaks, is next to 1 hydrogen. That must be this one. This CH3 has 3 peaks, must be next to 2 hydrogens. So I'm going to put the CH3 group over here. I'm going to connect this to the oxygen, and this is going to be on the end. I'm going to put it on the C double bond O. Once I do this, this will come up and form the correct structure. Now just for fun, I'm going to put this over here and see what happens when I click on Finish Setup. It says your structure is incorrect. So I can continue the activity and correct the structure, and then click on Finish Setup, and it says my structure is correct. So you get feedback when your structure is correct, as long as it's oriented properly. And it will always be oriented properly as long as you followed my advice regarding the rotation of only methyl groups in the structures. As I said, if you do run into problems and you need the answer, you can go find it in the answer file at the top of the exercise.